All right, well, welcome everybody to the second in our series of lectures this semester at the Edna Anderson Taylor Communication Institute. I'm very honored to introduce my longtime friend and colleague, Hector Postigo, who is associate professor at the Klein College of Communication at Temple University, specializing in digital media cultural production, and intellectual property. With postgraduate degrees in science and technology studies, as well as physiology and neurobiology, his interdisciplinary work explores neural networks, philosophy of mind, the shifting dynamics of copyright law, and AI-generated content in the creative industries, along with user behavior and digital markets. His research spans the evolution of digital platforms and business models, having predicted key trends in Twitch, YouTube, gaming, Steam, and user-generated content markets. His early studies examined the market for the market value of fan-made modifications in gaming, the motivations behind free labor in digital culture, and the rise of video game commentary on YouTube, as well as moderator communities on AOL. He has been the author of a generative book on hacking networks and intellectual property challenges, published by MIT Press under the Creative Commons license. I think it's one of the first Creative Commons
I had to twist their arms,
MIT, right? Yeah.
Otherwise, it would have been hypocritical to critique copyright and not.
Right. He's co-edited a volume on international security, privacy, and branding, funded by the European Commission. His recent work examines AI models like GPT variants from OpenAI, open source models hosted on Hugging Face, and other transformer variants to understand their impact on music, writing, and creative production markets. Between 2018 and 2022, his work on AI-generated music and natural language processing was featured in the New York Times, highlighting the evolving relationship between AI and creative industries. He created a policy writing model by fine-tuning GPT-2 for Rutgers School of Law's Institute for Information Policy and Law, and has delivered talks for Google Talks on YouTube and Yale School of Law discussing digital labor and open design principles' impact on innovation. He's also presented research on copyright, machine learning, and AI-generated content for the U.S. Copyright Society, Stanford's Electrical Engineering Department Colloquium on Computer Systems, the Pennsylvania Bar Intellectual Property Law Institute, and TTI Vanguard, and an Advanced Technology Research Association for senior-level executives on market benefits of client-side open-source models. He held prestigious research fellowships at Yale Law School's Information Society Project, Stanford University Center for Advanced Study of Social and Behavioral Sciences, RIIPL, what is that?
That's the Rutgers Information Institute on Policy for Policy and Law.
Yeah, that's a lot of letters.
Must
be important.
Rest in peace.
And finally, the Microsoft Research New England. So with that, I will turn it over to Hector Postigo. Basically, the TLDR there is he's very important. A lot of people know him. But he has many leather-bound books.
This is natural. I like to hide.
Okay.
Okay, thank you all for coming. I appreciate it. If you're if you can't see, don't be afraid. Just come on up. The reason I have this donkey is because Sean. One time I gave a talk at Santa Clara Law School. They flew me out, and then they switched it up on me, and I just didn't know what I was doing. I was a graduate student, and I told Sean, I said, I feel like a donkey, because I just sat there, and so now and then he just calls me donkey, so I figured I'd put donkey on there. So I've been working a lot with these models because it was so easy to hack them when they first came out that I thought if I can do it, anybody can do it, which means there's an opportunity for the media industries to intervene and to teach students how to do these things, to teach anyone how to do these things, and they can then use them. Of course, we have the ethical obligation to teach them how to do it right. And as you saw from my mini demo of the DeepSeek implementation in here, they do bake in some guardrails, but I know how to take those guardrails off. So they can be removed. Anyway, let me begin. Okay, I'm going to talk to you about a little ethnographic note, right? This project began somewhere around 2018. I'm going to read also. If those of you who know me know that I hate to read. I'm much more organic, but if I don't read, I'm going to get off script, and we won't finish. So the project began in early 2018 while I was in a year-long fellowship at CASBIS. Researching AI was not the primary purpose of my time there, but AI was in the water. AI appeared to be drawing a lot of talent, and I learned a lot of folks from from people I met by loitering in parking lots or riding random elevators and just talking to people. So one develops a kind of vocabulary when talking about artificial intelligence that's difficult to separate from how we reference people. So when I say things like AI sees or hears, things like that, what I mean is that algorithms that make up an AI's logic structure transform content like writing or pictures or music into probabilistic representations which probabilistic representations from which relational functions between them can be calculated, accessed as needed, and predictions made based on, number one, absolutely certain starting conditions, or predictions on most likely starting conditions when inferring them from conditions, or let's say parameters that are not certain. So that's why I have this example over here of x plus y. In the first one, if you see x plus y equals 2 and you have this parameter, all variables must be non-zero integers, positive non-zero integers, then these two can only be 1, right? However, using that same thing and getting 5, x could be 2, y could be 3, or x could be 3, or y could be 1. That's called irreversibility. It's the nature of why, for example, AI has a difficult time understanding metaphor, or simile, or idioms that are baked into English languages or any kind of languages. It just can't go backwards. If it doesn't know how you got there, it starts to guess where you may be coming from so it can create meaning algorithms going forward. So that's sort of the idea how it works. Any questions so far? Okay, next. All right, so let's start with a little bit of history on milestones of the AI progression evolution up to this moment. Beginning in 2017, Google published a generative paper called Attention is All You Need, which at first I thought it was something I could tell my students and just assign it, and it's actually computer science, right? So if anybody's familiar with that paper, it just teaches, it presents a new way of designing learning machines. The paper introduced the transformer model, which revolutionized language processing. Unlike previous sequential models, like you might have heard recurrent neural nets or convolutional neural nets, the transformer variants rely on self-attention, which allows them to analyze all the words in a sentence simultaneously and determine their contextual importance. A crucial enhancement in that was the multi-head attention, where multiple self-attention mechanisms run in parallel, capturing diverse relationships with such as grammar, meaning, and emphasis. And this is why a GPU, a commercial GPU that is designed to have parallelized systems in the way it processes information, is particularly well made for this kind of design. It can do this much better, and this is why things like a GPT model can be adopted, for example, on a laptop, right? Because it's basically designed for that kind of parallelization. All right, since transformers do not inherently process words in order, they use positional encoding, which is over there. Yeah, positional encoding. Now, what that does is maintain the location of that word in the sequence in the sentence so that the machine can understand where that word was prior. But it's doing it all at the same time. So the process is analogous. Let me just read my notes. The process is analogous to how we read logographs. Like, for example, the sign in front of a, let's say the symbol in front of a restroom, or the crosswalk, right? There's someone, right? So you can think of, right, a logograph is meant to convey a complex idea versus a sentence. A sentence would be, you may walk now, right? And you would have to read it and hear it. But if you see the walking person, then you walk. All right. So unlike reading sentences where you need to read each word before we know what it means and then reference it in the context of the whole sentences, the logograph will do it all in one shot, right? So that's basically more or less how the machine is thinking, right? So that architecture enables for faster computation, scalable computation. In other words, you can scale up pretty quickly, and more accurate language processing. And the trick here is a lot of the models that you see that are processing. Is anybody here with a computer science background by any chance? If you don't, that's fine. Just any questions that come up, just let me know. If the reason these machine learning processes are particularly well suited for, let's say, accuracy is because they can check their own probabilities as they create the model. So if they take the whole sentence and the word structure across, and then they can reference whether it's probable that that model will work in the next word. And so they increasingly improve their probabilities as they go. That significantly decreased the amount of time it takes to train one of these things. Okay, so that's the general analysis. Okay, so in early 2018, OpenAI released GPT-1 under an, did this go? No. Okay, so where are we? Oh no, we gotta go back, sorry. This is the timeline. All right, so in early 2018, OpenAI released GPT-1 under an open source license. And in October 2018, Google released BERT. BERT is also a transformer-based model. The timeline shows development of open source and OpenAI's open source and proprietary models along with the Meta and others, and that's where I have all the open source models there highlighted. That summer, the summer of 2018, I worked with LLMs, and like Sean mentioned, I trained a lot of GPT-2 models to make things like policy and law language models, or one time I made one for Sean that had him think that I was a military policy wonk because I just fine-tuned the GPT-2 to make me all my text sound like I knew what I was talking about, which I did not, but I fine-tuned it to do so. So since 2019, the term fine-tuning has evolved into transfer learning. When someone says a point on nomenclature, on naming, right? When someone says that they've trained a model, it's worth clarifying. Training builds a model from scratch. Fine-tuning refines a pre-trained model with a smaller, specialized data set that processes, and the process tailors outputs for specific tasks like language completion, Q&A, let's say about military policy or technology or communication or rhetoric, whatever it is. But if you focus it on that, then the machine, the GPT-2, will then produce outputs that generate in that vein. All right, so next. Okay, now this explanation about this. Back then, I fine-tuned a few GPT-2 variants, like I mentioned before, and I presented those to a number of organizations. And what you see here on your right is the process of fine-tuning GPT-2. Here, I'm fine-tuning it to make poetry at first, and I'm using a William Butler Yeats, right? Brown penny, if you know that poem. And then I give it a prompt. I could give it the first line of any of the Yeats poems, and it'll complete something in the vibe of Yeats, but not Yeats. And what I do is I check for any plagiarism. So then I write another algorithm that will then check the training, the fine-tuning corpus data set to see if I've plagiarized anything. And if I haven't, arguably I could become the next sort of William Butler Yeats, right? I also taught it in this run, and there's some outputs. I also teach it how to make music. In that case, I transform, I convert any MP3 into a MIDI format. If you guys do music and have seen, it's a visual representation of music, and then it learns musical pattern based upon visual representation of music, just pixel associations really, creates probabilities, and then deploys new music. Okay, and the whole point is to show that I could do that with pretty much, bare bones. This was 2018. 2019, and I'm running something, and this is my old laptop. I called it Deep 2 because the other one's called Deep 1. And I'm running in here, I'm running an RTX 2070, which has something like 8 gigabytes of video RAM. I actually had to hack GPT-2 to change the data chunks that gets fed into that card so that it could actually do what I wanted it to do, but meaning that I can hack at someone with minimum, I don't have a computer science degree, but someone with time and motivation can do it. Right? You can learn and do it. So that means that I can teach my students in communication how to do it. If I can do it, they can do it. Okay, so I saw a big opportunity because of this possibility. However, the opportunity to fine-tune GPT locally stopped when OpenAI did not make the pre-trained model for GPT-3 available for download, so I couldn't hack it. I had beta access to it and spoke to one of my contacts. I made friends at OpenAI, and they asked, I asked them why they had done that since since that keeps users from fine-tuning and makes it more difficult to mitigate against biases in the training set. So for example, if I take out GPT-2 out of the box and ask it to, if I give it a riddle, like a boy and his father go out for a fishing trip, and the father is killed, and the boy is raced to the hospital, and the surgeon walks in and says, "I can't operate on this boy. He's my son." Who is the surgeon? The mom. Right. But it won't know that. It won't know that. And I asked it to tell me a story about a judge. It's a guy. I asked it to tell it a story about a doctor. It's a guy. I asked it to tell me what color that doctor's skin is. It's white, right? So in other words, you have to fine-tune something like GPT-2 with a corpus, let's say that you download it from, let's say, I don't know, the census data that shows that more women doctors are working in the United States than men doctors, right? To make it more realistic in its extrapolation of what reality is, right? So in that sense, I could do that. GPT-3 is different. GPT-3, you can't access it. You have an API, which means that you don't have access. Those are the sources if anybody was interested. Okay, so that opportunity sort of vanished, right? They believed that you could use something like one-shot learning, which means that if the user has to be super specific about what the output needs to be. In other words, you need to tell it. If you wanted to tell you a story about a judge, you need to tell it significant details of what that judge looks like, who they are. Otherwise, it'll default to the bias, right? But if I can't hack at the code, and then I have to hopefully create a prompt that the machine will understand. Then began the practice of prompt engineering. So it went something like fine-tuning to transfer learning, and now it's called prompt engineering. How to craft a prompt that the AI will understand, and you get exactly what you need and inoculate against bias or anything like that. All right. So these are, now, once I had a good understanding of how these things work, I wanted to see, and OpenAI had shifted their focus. I thought, this is bad for the market. The market is the opportunity for, let's say, bottom-up production of these things, and especially teaching in a communication department. I thought, I could teach my students this, but now I can't. This isn't good. Maybe there's open source models that I can use, like GPT-2 was an open source model. So here are my research goals. Briefly, I began by collecting and reviewing historical data on Linux. Linux is an open source operating system, so I thought I need a template for a successful open source market, right? And I compared that to the Windows servers market over time to show empirically that the open source markets, which I'll abbreviate OSS, if you hear me say OSS, that's what I mean. Markets in this space have better valuation distributions than the proprietary markets. I did that by finding indicators that I could correlate with open source market success compared to Windows, so I could illustrate that rapidly emerging AI open source markets are on the same track as the markets that have previously succeeded over proprietary spaces. All right. Then I applied heuristics, such as the prisoner's dilemma. If anybody's not familiar with the prisoner's dilemma, it's a game theory framework, but it's also been used in economics. To illustrate, I use that to illustrate that open source market norms, as opposed to proprietary market norms. So now we're talking not just laws but norms, what people believe in their space, right? Norms and regulations like copyright can lead to divergent outcomes. I reviewed legal precedents, evolving policies, historically the AHRA, Universal versus Sony, and then most recently Authors Guild versus Google. I'll reference that case as the Google case. And also Routers versus Ross, which just was settled last month, and I'll refer to that one as Routers. I wanted to illustrate how emerging jurisprudence could either help or hinder long-term optimal valuation for these markets. And the OSS market structure is also spreads value laterally, right? Meaning that there are many actors in that space as opposed to very few, right? Which create a long-term, more stable valuation and progress and diversity and outcomes, right? It's not just one way, it's many ways. Are we good? All right, raise your hands, questions anytime. All right, this is the penguin, that's Linux. All right, so first, let's delve into the Linux market dynamics and financials. These are what I dove into. let's see. I've gathered economic data from financial performance, for Linux-based systems like Red Hat, Ubuntu. Well, Canonical is the parent company of Ubuntu, SUSE, and IBM Linux resources. I also looked at SEC filings. I also analyzed, it's not, did I put it on here? Yes, cloud dominance. I also analyzed broader market trends, trying to observe shifts in proprietary solutions towards Linux enterprise server systems and their application in the cloud. In other words, how many cloud-based systems use Linux instead of any other server system, right? Then I also analyzed community contributions, which happen to be very critical, as I've monitored GitHub and GitLab data, along with reports from organizations like Gartner, Forrester, these are market research firms, but also the Linux Foundation and the Linux Foundation AI initiative. This approach provides clear, data-driven perspectives on Linux's evolving role in the open source market compared to Windows, and will give me a template for, that I can make a reasonable, data-driven argument about why we need to adopt an OSS-style market for open source for AI. Any questions so far? All right, so here we go, some initial data on Linux, right? And this is going to be the implementations of Linux. Here you find data on valuation history from Red Hat, SUSE, and Canonical. From just these entries, we see a sustained growth revenue throughout its history, beginning somewhere in 1999 with an IPO of $42 million for Red Hat. All the way up to 2019, and then in 2019 there was a significant spike, it's not listed here, when IBM acquired Linux for, Red Hat, sorry, for $42 billion. So over time, this has been a significant valuation. The same thing for SUSE and the same thing for Canonical. Canonical lags a little behind, but they have SUSE does have a niche market space in the server market. All right. Any questions so far of these numbers? All right, next. Oh, God, graphs. It's been a long time since I had to really deploy the quantitative side of my brain, so I still have this anxiety. I used to be a qualitative researcher in the communication space, but now I'm doing quantitative work, so it's a little weird for me. But I'm used to it. All right. So here's some data presented graphically. The first graph shows that $42 million initial, and then the $3.4 billion in 2019, based on subscription-based models that Red Hat converted to, and then there was a $34 billion acquisition by IBM. The next graph shows SUSE, and it shows its rapid growth from its rapid growth throughout, I guess, 2020 through 2023. Which means it's dominating a market. It's got a specifically niche market in clouds, in cloud computing. So it competes quite well with Linux, right? But the picture I'm trying to paint is one of diversity. These are different implementations of the same OS solving different problems for different people, designed by the people who define the problems for themselves, right? So therefore, you have a much broader market. Lastly, you have Ubuntu's parent company's valuation, that's Canonical, and also you see a rapid spike. Taken together, I think no one can deny that this is a success story of an open source market, and the valuation is strong. Well, how about, all right, you might think, that's great, but what's it compare like to Windows? Windows sucks, comparatively, right? This is the history of Windows penetration in the server market. Here's Windows taking a dive, and there's the penetration for the Linux market. And these are normalized so that some of these data will be normalized so that we can compare apples to oranges sometimes. All right, so in sum, the first figure shows that Linux grew 40%, 55.4% by 2025, and Windows Server is down 20% to 11.9% of the market. So they're losing ground, have lost all the ground they're going to lose. I think they're just going to plateau there and not come back. The second figure shows cloud dominance by the open source markets, right? And this means this is adoption by any Linux type system by things like AWS, Google Cloud, or Azure. So that's an open source initiative. So think about AWS, which basically runs the backbone of the entire web, right? And they're running open source software. So this is a success story again. The third figure over here has compounded annual growth rate for Linux companies. And in the lead, you have Red Hat, which we knew that, but also Canonical is coming up pretty fast. Again, that's an indication that a niche product, right, for a group of people to design it for a particular thing is making inroads among those communities that need that, right? And it wasn't, let's say, an intellectual property owner that decided it was time to break into that market, and so people sort of have to pay high prices for something. Someone was already producing it. The last figure is a count of commits, and this is GitHub data, of implementations of variants of Linux operating systems for various reasons, right? So you see that growth from 2010 all the way up to 2022 in the upwards of 22,000 contributions to the Linux ecosystem. So not only do you have wide market penetration, but you have a vibrant user community that continuously hacks and improves or changes or does things to it, which means that these folks are benefiting from free labor, right? This is free labor. But in a good way, I would say. Of all the ways you can exploit free labor, this might be the best way possible, because a lot of the times these communities are interchanging and there's a lot of value being shifted. Some people get hired, other people become leaders in the community, they get to define the way this thing goes. Other times people forgotten, or they design something nobody wants, or it's pernicious in some way. But these markets have ways of policing, disciplining outliers, or people who go against the norms. Any questions so far? More graphs. I am so sorry. All right. This slide highlights parallels in the. Now I'm comparing AI market, OSS, open source markets, with Linux markets, right? And what I've done here is normalized for time. These are the first 6 years of Linux versus the first 6 years of GPT, of Transformer. So my starting date, right, for Transformer is 28, for the GPT, the current situation in AI is 2018, which is when the Transformer model was released. And I've normalized everything to account for the first 6 years of Linux, which was way back when, right, in like 1999. Okay, first we see faster valuation trends for open source AI markets. Faster meaning there's the slope is steep. In other words, comparatively, open AI markets are growing faster. Open source AI markets are growing faster than the proprietary markets. Next, we see investment trends. Open source AI attracts more investment capital. It's attracting more investment capital compared to Linux. And that's, sorry, I should tell you, the red hashed versus the blue hashed is the market valuation. The yellow hashed versus the solid green line is the comparison between investments on open source AI models versus proprietary models. And then we have a comparison between enterprise adoption of these open source versus proprietary models. And that will be what remains. I guess it would be the green. Are we good? Okay. But in the third case, with the enterprise adoption, the curve for open source AI closely mirrors the Linux case. So that would be down here. Yeah, Linux enterprise adoption, that's this one. So that means that this thing is, the open source AI market is behaving just like the very successful open source Linux market. If you want to use this as a predictive model, then this is sort of a predictive model for where it's going to go, unless something gets in the way. All right, so next. Let me know if I'm going too fast or if I'm running out of time. Okay, this is a comparison of platform distributions of open source AI models before Transformer, after GPT-1 and 2, and then after DeepSeek releases. So 2019, right, we have number of major AI models, dominant platforms distributing them, specialized model repositories, and you can read the rest. This is before Transformer. This is after Transformer, but before DeepSeek, and now DeepSeek, right? Tens of thousands compared to. So you see that spike I was talking about? That means that these contributions in the OpenAI space, in the OSS space, not OpenAI, I keep forgetting it. It's not. There's a joke going around, us hackers that work with this. Yeah, OpenAI ain't so open. So it's not so open. So it's open source, really. So you can see how quick the implementations have been appearing in this market. Okay, any questions so far? Next. What if we want to use a different comparison? What if valuation, fine, and maybe, you know, if you take Windows all together, they will have an ultimate higher valuation in the market? Well, all right, but if we're going to talk about rational actor theory versus a game theory that says rational actor thinking is not always the best thinking in evaluating and creating valuation, then you might want to ask, well, what's the return on investment? In other words, when an average company has to invest $1, how much do they get back in their investment when you compare proprietary returns versus open source returns, right? So here, in server infrastructure, if you $1 spent brings you back $3.50. If you invest, and that's all beats, by the way, the percentages are how much you beat Microsoft or proprietary by. So in other words, let's say some data suggests that total market valuation, proprietary over time, because it has such a head start over Linux, is higher. But over time, the ROI is way better. So there is no reason why not to adopt it in this manner. There really is, if you're thinking like a rational actor, other than controlling a market, there really is no reason to not adopt it. So now for the prisoner's dilemma. So now we have to think about market norms. If we can say that the figures suggest that there is no reason why we shouldn't be embracing, or a company shouldn't be embracing, thinking about the whole market, why aren't they? So we have to talk about market norms. Is anyone here familiar with the prisoner's dilemma from game theory? I'm going to walk folks through it if you're not, just in case. So if you're familiar, the prisoner's dilemma has been applied to intellectual property markets, to copyright markets. Economists have shown that cooperation, sharing via open source licensing, for example, increases likelihood of success compared to not sharing. Even if not sharing results in the unlikely case of success, the whole market value is attenuated, is lowered, because the norm of strict copyright for not sharing source code or allowing derivative works slows pace of innovation, diversity in design, and entries into the market, as was demonstrated with the comparison between Windows and Linux, right? So we know this, we've seen it. So this slide is meant to illustrate the kinds of choices that the norms structure, right? So for example, this is a hypothetical. Let's say we have two competitors. I always run this in class. I tell my students, all right, who wants to play a game, right? And so we have this moment, but this is economics, and they enjoy it, I guess, because I tell them it's a game and they don't realize they're learning economics. Okay, so let's say we have two competitors, A and B, each have different halves of a solution for an innovation, right? Eventually, they may each solve it, but there's a low probability of that. It'll take longer, and if one beats the other will lose out if this game is played by the proprietary players. So, should they race each other? Should they bamboozle each other? Or cooperate? That's the question of the game. If this is a proprietary market, there's only one legal option: to not share. They could bamboozle each other, right? They could lie, they could defraud each other. Yeah, I'll tell you what I have, you tell me what I have. They could bamboozle each other, but then they would face social and legal consequences. So, assuming we're not talking about Elizabeth Holmes, if anybody knows who Elizabeth Holmes, you'll get the joke. As long as we're not talking about Elizabeth Holmes, then not sharing is the only way proprietary players can play this game, right? Now, this is the fun part. If it's an open source market, sharing is the only option for reasons I'll review later and when I go over their norms. But let's get through the game's conditions. The total value of the whole market, let's say if both players enter, the market is 140 million, right? That's like 70 plus 70, right? However, if only one enters under strict copyright, the other doesn't. Being a sole player in the market, we can assume the rate limiting step for the market growth, or that one player's ability to exploit the market, will be things like limits and scaling, right? If you're the only player and everybody's coming to you for the innovation, this is like I actually consulted a bit for McKinsey & Company, and this is the problem in success, that scaling loses clients, and then that's it, the end. So scaling is the first problem that any growing business will confront. Smaller consumer bases, because the pricing in services and licensing is not competitive. So the one owner of the one innovation gets to define it throughout. You might know, if you've used ChatGPT, they've changed their pricing structure recently. So now you pay $200 a month for the pro version of the models versus the $20 for so you get it, right? So that's a lot for the average consumer. A lot for a starting business who wants to deploy let's say ChatGPT. So then there are other external costs like hiring R&D. The R&D cost is quite large, right? So there will be other external costs. So that's why if they don't share but they get it, they only get 100 million, right? Because you have scaling limitations, you have limitations on talent, you have to reinvest a lot more money in R&D because you don't have those 10,000 commits on GitHub for your new model, right? That you can use for your own purposes. So, okay. So, in a proprietary market, you could get that. You could get 100 million, but the probability, again, is very low or low in comparison. So this is where probabilities start to... I learned a lot when if anyone's read the book Future Forecasting by Philip Tetlock out of University of Pennsylvania, you learn how to think like a bettor almost at everything you do. Like, will this road be the most optimal? What are the probabilities that I'll get to my meeting on time? What are the probabilities that this suit will get me the job, right? But we do this as a heuristic. We don't actually sit there and crunch numbers. It exists over there, right? So we started to think. So I started thinking in these terms, and I think maybe they think in these terms, but let's think in these terms ourselves. If you're stuck without a solution, then the probability that you're going to get the solution has to be less than 100%, right? So would you rather have 100% of half of something? No, 50% of 140 million, or a less than 100% chance of getting 100 million, right? 100% probability that you'll get $70 million if you share, or a less than 100% probability that you'll get the $100 million all to yourself. A rational actor would take the safe bet, the sure bet, 100%. You're going to get it. But stuck in a copyright proprietary system, the norms dictate that you don't, right? So you're stuck. These people are these markets are stuck in that thinking. That's how they think. That's how they operate. So they're happy to take that really bad bet. It's just a bad bet. Any questions so far on how this applies in terms of norms? Now, you might be wondering, so what makes them so different other than the proprietary thing? If you think about these communities as, let's say, cultural spaces, right, where people have values that are intangible, that are meaningful in different ways, they think of relationships. So the business relationship in an open source market tends to be a long-term relationship, unlike proprietary systems, where you have an ongoing strategic interaction with others that you've had for a long period of time. There's also a norm of reciprocity. So if for example, Meta releases the Llama model as an open source model, then Mistral released its model as open source. So if you're participating in this space, if one company does it, the other does it, and so there's this norm of reciprocity. It turns out if there is a failure in that reciprocity, then this particular market turns its back on you. So there's punishment for not obeying the norms. What's interesting, really interesting about reciprocity is if you're familiar with Annalise Saxenian's work on comparative advantage, she did a study of Silicon Valley versus Route 128 in Boston. Everybody knows what Silicon Valley is, yeah? Not so much Route 128, yeah? Yeah, exactly, because of the norms. Actually, Silicon Valley has a strong sharing norms. You go out with people, you talk, you loiter in parking lots, you talk to randoms in the elevator, you go to bars, and you tell them what others might consider is trade secret, but you don't, you share, right? And as a whole, the entire industry succeeds. This is where 128, no one knows what they are, and everybody knows what Silicon Valley is. There's also rational actor cooperation, even though it might not look like these folks are behaving like rational actors. They're not being entirely self-interested. They're conforming to norms of sharing. And it's rational actor cooperation because free riding can be punished. And that creates a balance in the types of incentives that people have to stay or leave. So, next. These are the ways in which the open source market mitigates defection. Because it's an open source market, it tends to be more transparent as to what people are up to. So you can tell when one company or one group is not sharing innovation because it's transparent. There's transparency, right? If one company just keeps sucking up, if one group keeps just sucking up innovation while never contributing, then or they say they did something, but yet they start selling it on the other side, back end, doing something else, and you know that they're cheating at the game, right? And there's like a punishment system, which is, again, the market turns its back on you and you're on your own. Also, the punishment for defection it can happen across, it doesn't matter what size. So for example, if Meta decides to reposition Llama as a proprietary open source, a proprietary AI, the market will people designing for other AI systems will stop making their AI systems operable with Llama. So that's nice, right? That's nice that you went proprietary, but since by the time that happens, they're going to control something like 60% of the market. Good luck with that, Zuckerberg, right? Good luck with that. Leadership stabilizes the space as well, and the important thing is there's not one leader. There are many leaders. So you have organizations like Hugging Face, Olama, or the Linux Foundation Open Source AI Initiative. So there's organizations that create and reinforce these norms and reward these norms with funding even, right? So there's stabilization, and no one leader can go one way without a consensus, or not consensus, but at least debate, right? Okay. So they're self-regulating. And if you really are interested in future forecasting, this is my prediction. By 2035, the open source valuation will be at 5.1 trillion for open source market AI, with a proprietary at 3.7. But I'd rather have 3.1 trillion if you're thinking like a rational actor, right? So something to point out. Let's see. Historically, valuation data and growth projections support these findings, right? I would bet the farm on them. You know how they tell you, would you bet on it? I bet the farm on it. And if anyone wants to take that bet, I'll bet you. People stop asking me to come to talk sometimes because I'll bet you not, and I really mean it. Or I'll bet you. So higher growth. Okay, so what's happened? AI has shown higher growth rates, which are showing something like 13% compared to 8% in the proprietary space. So they're growing faster. And you compound those percentages over time, they're going to grow. DeepSeek's release has really changed everything and has significantly accelerated the growth of the open source space. Next is scaling efficiency. Because of collaborative development, these systems are faster to scale, so you don't have this problem that you would have if you're the only player in the field and everybody wants to play, right? Next, let's see, we have scaling efficiency, faster scaling, right, and then proprietary systems. And last but not least, what else was the one that I really wanted? Oh, the parallels. The parallels I use the parallels to the Linux success to predict this trajectory is what I'm trying to triangulate the future, if you will, right? So I think I've done a pretty good job at it, but you're welcome to tell me I suck. All right, so what is the thing that might get in the way? What is the thing that might stop this process from happening? And I've been called a copyright anarchist. I think copyright is a bad idea for this space. But there is a high incentive to pursue copyright because of market norms and because, well, maybe you get money, right? Maybe you get that legal monopoly, which is copyright over the development of this space, which is just getting started, right? So there's a high incentive. Monopoly is a high incentive. However, it's risky, and it's a short-term gain, and in the long term, it's not good for the whole market. Whoa, did this thing turn off? Oh, there we go. Yeah. So what I'm going to talk about, first of all, I think copyright's going to be a problem. I'm going to show you why copyright law is a problem. Okay. Remember the VCR? Yeah, right? Yeah, you do, right? Back then, the 80s, the Motion Picture Association of America had a representative. His name is Jack Valenti, and he got in front of Congress and said the following: the VCR is to the movie industry what the Boston Strangler is to a woman home alone. He said that in front of Congress. You can thank the Supreme Court of the United States circa 1984 for your VCRs, your DVD players, your iPads, and Netflix, and any streaming video that you use right now. You can thank them for that. What's that market worth now? I don't know. I'm still counting in the trillions, right? So these laws would have gotten in the way of this market valuation across. Think about all the businesses that traded on the VCR, Blockbuster. Think of the things that emerged because of the VCR, right? Okay, so does anybody remember the digital audio tape? Of course, you do. Oh my goodness, good for you, because someone had to tell me that thing existed once upon. Did you own one? They were pricey, even for like the 1980s standards. They were like $1,200, yeah? So anyway, but no one else would remember them, right? That's because the music industry, the MPAA, no, it's not MPAA, I forget, oh, there it is, the RIAA, there's so many letters. The Recording Industry Association of America got ahead. They learned from the MPAA's mistake. So they got ahead of it, and through litigation and lobbying, pretty much bullied the manufacturers of that tech out of existence, or stymied that market long enough to have the AHRA, the Audio Home Recording Act, passed. And by the time it was passed, the following two stipulations were given to any manufacturer who wanted to be able to play any creative industry content on a digital audio tape. You had to pay a steep royalty, and you had to create a degradation system in copying. In other words, making that digital audio tape player recorder that could make high fidelity reproductions of something, not much better than the magnetic tape, right? So why pay the $1,300 for a digital audio tape player recorder when you can buy one for like $50, right? I mean, you get a magnetic tape, and quality's more or less similar. So, which leads us to the current attempts by copyright owners to take control of the AI market. This is happening as we speak, by suing like it's a religion. I swear to God, they're suing like it's a religion. Right now in the courts, it's not AI companies suing other AI companies for violating copyright, though that's in the awning, that's coming, but it's media industries or other copyright holders suing AI companies for copying content and transforming it into data for other uses, like in the Google case we'll talk about, or to train models that will then make goods that have no or limited discernible similarity to any work that the model outputs that may compete with the content in the training corpus. In other words, imagine I use a bunch of books to make a language model, and I have it make books. As long as I check there's no overfitting, I'm not plagiarizing, nothing that I produce will look like anything in my training data set. As long as I check for it, I can assure you it can be done. It's a simple script you can write, and it just checks the entire data set, especially in fine-tuning. And fine-tunings are smaller data sets, so you can scan those data sets with Control Find if you feel like it, right? Okay. So with that in mind, we're going to cover, sorry, we go back. Oh, this is my description. We're going to cover the routers case. Where is it? We're going to cover the routers. We're going to start with the Google case, move on to the routers case. We won't have time to work with Getty Images. I know folks at Getty. I've debated the attorneys, the chief attorneys at Getty. And we're panel buddies. We're frenemies, though. We fight. It's great to watch us go. But we'll start with the Google case, because that really is definitive. Oh, and this, let's see, the Google case. Let's see, yeah. In the Google's case, let's talk about this one. Many attorneys will argue that the Thomson routers case, the other one that I'm going to talk about, has definitively settled the matter that fair use can no longer be a defense against infringement. Is it time? Do I need to go? Oh, I'm over. All right. I disagree. So the case of Google, I'll go really fast. Google took a bunch, in the Google Books project, took a bunch of books, transformed it into a data model so that people can search them, right? Google got sued by the Authors Guild because they had copied. But the courts that reviewed the case said, no, that's transformative. You had something that was expressive, and it became a probabilistic model, which no one can appreciate, really. No human being. A machine might be able to do something with it, but we can't. Therefore, it's fair and transformative. What the court didn't think about was the future. This was a 2015 case, right? I thought about it when I first gave this talk back in 2019. I said, this error should have existed back then, because what the judge should have known was that it's possible to put new content out there based upon this model that will compete in the same market as the stuff that was over here, and had the opportunity to create exemptions for those moments, right? That create exemptions, for example, that state that a data set should be, it's okay to create a model. If you're going to create competing works, then the competing works cannot have any substantial similarity for anything in the data set and should mandate makers of these data sets to make them publicly available for review, just in case the outputs are plagiarizing what's happening. The courts had the opportunity to do that, but they could not foresee into the future. It's 2015. These models didn't exist. These capacities didn't exist. Which brings us to routers. This got settled last month. A lot of attorneys will tell you that this kills the fair use defense, right? The transformative use defense, and I'll tell them they're wrong. And the reason they're wrong is they're wrong for a number of reasons, and I'm going to summarize all the stuff I had. Number one, what Ross did was extract data. There's a concept of intermediate copying. Intermediate copying is a reverse engineering allowance. You can copy a program if your purposes are to reverse engineer its functionality so you can design another program that will create interoperability. You can do that. The copying is fair because you're using it to figure out the functioning of that one piece of software. The Ross people who had copied all of Thomson routers, which is Westlaw, had copied all of their head notes, used that as a defense. They said, we can't have an AI unless we give it a data set, and that's the data set. But the judge found that applied what's called the Warhol principle. In other words, the bar is super high as to what the transformation has to be. The judge applied something that was meant for software re-engineering or reverse engineering to a training process, which are not analogous at all, right? So that judge missed that boat, and ultimately the judge found in favor of Westlaw, not necessarily because they had violated any copyright statute per se, let's say in their sale. What they had failed to do was really hire a machine learning specialist that would do the overfitting check. In other words, to make sure that nothing that was being presented by Ross Intelligence looked too much like what Westlaw was producing. If they had done that, they would have won this case. They just needed better staff. It's very clear that what the finding was, and people have tried to argue with me and say, hey, this is definitely no, this is you copied exactly and sold it, or it looked too much like the original, and therefore you can't say in the same market that it was this, you can't use a transformative use. So that's going to, I think, colleagues of mine at Chad Rotzkowski, who's he and I have been working together for a while now at Baker Hostetler, a law firm, international law firm. He's written extensively about this failure in this particular case, and he agrees with me on that. So this is the problem with existing copyright law right now and the court's interpretation. It's limited to software where it should be applied where actually what was being copied for the function was factual in the data set. The mistake was just presented exactly as Westlaw would present it, right? So copying the data set is fair. Copying the structure of the database is not, right? What they did is they presented the outputs in the same manner. So that was the problem. It was the head notes, right? Because the head notes are creative, right? Some editorial, someone took all that publicly available data, not subject to copyright, organized it in a certain way, and that's called creative editorial intervention, but released it, and the Ross people released it the same, but it's not the same if you don't release it in the same style, for example. Then it's just copying facts that are public anyway, so fair. Last, the copying was reasonably necessary. This is the Warhol test. The judge found that it wasn't reasonably necessary because that judge was thinking in terms of software reverse engineering, but AI doesn't copy to read or sell. AI copies to learn, to create probabilistic models. So the application of that standard is not correct. The court's interpretation then was, no, it didn't transform, but actually it did. It learned how to write legal language, and unfortunately, whoever they had working for them didn't bother to check to see if there was overfitting. The term for plagiarizing is overfitting. All right, all this come together. This is my summary slide, thank goodness. Sorry, AI is built for knowledge processing. Copyright was meant for humans, right? But AI is doing something entirely different. it's also protecting legacy business. It's cool for Google to make these incursions into copyrighted works by making copies and generating our model, but if a small startup does it, not so good. And the reason the Authors Guild was willing to accept the court's decision in that case was because someone made the argument that there actually would be a positive effect on the market for those books, because now they could easily be searched, snippets could be shown, and a potential buyer could be more interested in that book. So of course, major publishers were like, yeah, it's okay, you can use our stuff. And fair use law is not built for AI, it's built for humans. Again, AI is not, citing, critiquing, using it for education. It's a learning process. If you're going to charge anyone with let's say a violation, on whether something was fair or not, it has to be on the output, and it has to be on the overfitting. In other words, did it copy? Does it look enough like? Right? So I have musicologists. I've spoken to musicologists who want to figure out how deep do they need to look at the musical structure of an output that of new music to see if it may have been influenced by something it learned from its training corpus, right, and its training data set. To which I always respond, have you ever heard Bob Dylan's Tambourine Man? Have you heard Billy Joel's Piano Man? That's overfitting. So are you gonna, is Bob Dylan gonna sue Billy Joel? So I don't think I don't think it's a tenable, it lacks reason. And I think courts, as this legislature is shaped, as precedent is established, courts that know the record and know this history will not be able to apply the same thing that the judge in the Delaware case, the Ross case, did. Okay. So this is my recommendation for new kinds of fair use. Open source models and uses should have exemptions. So in other words, otherwise, no AI will exist ever, right? Number two, market benefits should be taken into account. So what I mean by that is benefits from using copyrighted works for making new models or improving them should outweigh imagined harms to copyright holders. If we can imagine market harm for one, why not imagine benefit for the other, or for the whole market, or harm for the one, because we're so worried about the harm for the other. So that's what you got. And really, at the end of the day, I think we're suffering collectively from focus bias. That we've gotten stuck on deep fakes and bias, things that we can correct if it's an open source model, right? And we're just worried about the one thing, and I get why. But along with that worry, we should probably be advocating for the other thing at the same time. That way we get what we want, right? It's a win-win. Okay. That's it. That's what I got. That's where my research has taken me so far. I'm pugnacious with attorneys. With anybody, I'm pretty passionate about this particular thing. Any questions?
Cool.
I'm sorry if I went fast. If you didn't get me, I was just running really fast.
That's good. That's
There's
good.
a lot of
He
stuff.
told me earlier today. It's like I timed it, and it's like the full hour and a half. And I'm like, no, it's not. I'm gonna cut you off.
And I tried to have one of the AI sort of do my editorial work, just hack and slash, right? And it wouldn't. Yes, you have a question?
I just have one slight question. So, aren't the copyrights, like for example in the case of an author, aren't they kind of just designed to say that, like an AI company is receiving value from selling their models, so an author should be compensated at least a portion of that value?
It
Isn't
is.
that kind of fair?
And that's the question, right? So the question is, if you have an exemption, let's say for training, you have to balance, it's called the balance of equities. If you're asking, let's say, copyright owners to surrender some portion of the potential earnings that they would have extracted had they not leveraged their copyrights, right? Then, because the copyright statute is based on the intellectual property statute in the Constitution, which says a limited monopoly from a limited time, in the purposes of serving society and the progress of the useful arts, right? So a lot of copyright statute only looks at what the benefit to the author is, but never uses the balance of equities model, right? To say, well, if we're asking the author to have a monopoly, what's society getting out of it? So the argument would be, strict copyright, we would have to ask authors to give up the potential for exploiting this particular line of the market, or take less so that the market could move along, right? Let's say in an open source system. In other words, open source companies can then have those negotiations with authors or creators, right? And have their models be open source, which means that the data sets are open and also the model themselves. So everybody wins. The copyright owner will get something, not as much as they would have gotten originally, but something, and the market grows. So that's the solution, right? It's a balance of equities. I see a fight. They're going to fight. Paul Reitnitz is the chief attorney, intellectual property attorney for Getty, and he and I love that guy. He's doing it, but when we just get together, and he's like, no. So they're in Europe right now. Getty's in Europe defining AI policy. So it'll be a fight. And unless, deep investment in legal and the argument and the judges start to buy the progress of the useful arts argument over the limited monopoly argument as an incentive, we will have a hard time with biases, correcting biases. We'll have to trust companies that they're correcting bias. We have to trust them about where it's going rather than see the code. Yep. Any other questions? Yes?
This is really interesting, thanks.
Yeah.
I'm curious about your projection markets.
Oh, my future forecasting?
Yeah, for OpenAI versus proprietary. And I'd like to hear you talk about how you imagine the new regime in the U.S. Affecting maybe these projections. My guess, it's truly just a guess, would be that it would favor proprietary models, but what do you think?
I think that what this is modeling is something that happened during the DMCA. The DMCA, the Digital Millennium Copyright, right, got in the game late, when Napster had come out already, right? And there was nothing. It was a code war. There was nothing putting it back. So the administration can do all it. At best, at worst, it could have DNS blocking, so you can't download any of this. But then we get into free speech problems, and this cat is out of the bag. So I think there would have to be some catastrophic network collapse for anyone to be able to stop this thing from rolling along the way it is. It just they could never put that. I was having a conversation with Fred von Lohman from the EFF about that. So yeah, once that cat is out of the bag, there's just no putting it back in. There's just no putting it back in. So I'll stand by it. Maybe not so much, but I'll still bet the farm on it. Any other questions? Yeah.
This is a real screwball question coming out of my area of environmental communication.
Yeah.
And one of the things I've been thinking a lot with AI is the environmental impacts of AI and the water usage, the electricity usage that goes into AI. I'm just curious, is there a difference between open source AI and proprietary AI in terms of those
Yeah,
energy
I thought of you, and I almost put that slide on here. Think about DeepSeek, right? I'm using a commercial GPU on the 14 billion model, parameter model, and I can run a business, an AI business on this thing with this thing's footprint, right? So the open source system will have a significant positive impact on the footprint. Yeah, yeah. It's a win-win. I can't see how it isn't. So, I mean, we will have people who will adopt these open systems to do pernicious things, to do objectionable things. There will be market harm, and there will be market retribution for those that do that, and they will have to have open source models, and we will have to look at them. We'll be able to look at them and mitigate whatever harm they attempt or hope to attempt, right, or hope to do. So the open system is the best. It's just good for everyone. It doesn't really have a losing side. Yes?
I might have missed that part because I was late teaching.
No worries.
So I'm wondering, like, what types of models you're looking at or data sets they use, because I mean there's some that are using sensitive information like patient data, etc., which you probably couldn't make that openly available, and if you do, you first have to mask
Right.
like,
Well, it depends on-
X-ray
yeah.
images or whatever. And so I'm wondering, like, what this relies on, and what would it look like for more sensitive models?
So I guess the question is, it's a use case application, right? So for example, in the United States, HIPAA would prevent any medical practitioner from sharing it. But I would bet money that our insurance companies are developing predictive models on our medical histories. If I was running that too, I'd be doing it, right? As a rational actor, I'd be doing it. So, well, I would not want to, but you know, my obligations to my investors would require me to do so. So the question really is not what the open source models are doing, but what the private models are doing behind closed doors. And without transparency, we can't know, right? So if insurance premiums go up or car insurance premiums go up. So the data sets that I used are all data sets for open source applications, and then publicly available information on anything proprietary. And mostly that was financial, because I can't know what's in a proprietary data set's corpus. I don't know what it is, right, because it's proprietary. But I can know, for example, what GPT-2 used and what GPT-1 used. I just don't know what GPT-3 used, or 4, or 4 Mini, or any of those, right? So that's a black box. So if they were able to, let's say, strike deals with metadata handlers, like for example, Google, who knows you went to a doctor, then you went to the pharmacy, then you went to an oncology center, then the likelihood. Google has a really good algorithm for predicting if you have pancreatic cancer, actually, just by your metadata. So that's what I worry about, but I can't know because it's hidden. So that's where my worries are, not necessarily the public stuff. The public stuff, as long as there's someone watching, you can see. Does that answer your question? You had another question back there?
I was just wondering if you see any opportunities for humanities majors in getting in AI-related.
Oh yeah, this is my students. The media industries, right, and the writers or humanities folks. We have to deal with cultural goods, whether it's our history, our curated history, right, or whether it's songs that touch people intimately, but that won't sell, so therefore they don't get made, right? So if you can give these tools to, I work at Temple University, predominantly African American. It's a very diverse place. There's a lot of African American, Latin American women of all. It's very so to give these folks those tools to tell their stories their way, to use these as a force multiplier, I cannot not do it. So I think the opportunity is vast. You just got to tell me what you want help with, and I'll make one for you.
Thank you. Yeah.
Any other questions?
I'll give you one last question. This is sort of based on a report that I was reading from Harvard that just came out the other day from Erica Chenoweth's work there on looking at the use of AI for pro-democracy resistance movements. They held a workshop back in December. The report on the findings from that workshop were just published, I think, last week, and I was reading them the other day. So you have ideas on how this stuff can be used to help folks in the humanities. What can, I know you've done research in social movements in the past as well. What are your thoughts on how generative AI can be used as force multiplier, as you say, for pro-democracy social movements at this critical moment that we find ourselves in?
So social
Because
movements.
the reason I ask this is because there's a lot of people in the resistance social movement space who very much hate AI at the moment, right?
I think
Because
it's
of
focused.
OpenAI.
I get why. I know why.
Yeah,
Yeah, I
Grok
get
and right?
They have reason to do so.
And they have good reason
Right.
for that. At the same time, there's an argument to be made that says, hey, we're outgunned, right? Like the bad guys are using AI. If we don't use it for something to help us, we're outgunned. So I guess my question to you is, what are those uses? What potential uses do you see as AI as a force multiplier for pro-democracy social movements, and how can that be done ethically?
Okay, so social movement research, right, has like sociology was one of the first disciplines to study it, and they have opportunity structure, right? Extra institutional tactics, right? And institutional tactics. So opportunity structure would mean like that the political system is or there are entities in power that are in your favor and they could help your social movement along. But let's say there's a lacuna in that, we're absent that. So that leaves us with things like institutional and exstitutional tactics, right? So for example, the model I designed for Rutgers was meant to produce a human-centered AI policy. I thought it was a great irony to use an AI to do it. But we can, for example, if we need to have people who don't know, let's say, everything there is to know about, let's say, a breach in some civil rights, some established civil right, they could produce a corpus fine-tuned on everything ever done, every said, written about this particular issue, could produce something very understandable. And you can tell the AI, I would like the average person, not an academic, not an expert, the average human to understand and be, no, and you can add and be persuaded. So it'll use things like enthymeme, it'll use things like, it'll suggest what kind of colors you can use in your pamphlet. Like for example, blue tends to be a very positive. It'll tell you how to do that, how to craft persuasive messages for what you want. Then there's extra institutional tactics, right? You can flood the stream with you can have as many AI producing, social movement disinformation as you like. You can flood the stream with it. Phone calls, emails. You can do all kinds of extra institutional disruptive things. But recruitment, making folks that persuading people that aren't necessarily invested in the movement become adherents to your movement. That means you have to help them see themselves in your struggle, right? Black Lives Matter struggled with that, right? The women's movement struggled with that. So it's also an act of persuasion, but also of analyzing patterns of speech, patterns of media consumption, and how to reach people in those ways. But the AI you can ask an AI, what would you imagine a person who is pro-democracy but doesn't share, let's say, my race, gender, or any designator, what would they find compelling about my issue? And it'll write something, let's say, someone who loves metal will understand this language, or someone who owns firearms will understand this message, right? To think of people, we cannot think of potential adherents to the social movement as monoliths, and these things.
Small social movement cell.
Yeah,
can have its own.
His
Strategic communication department.
Yeah.
In a box.
Right, in a box, and ask it to do so, to produce a message. And it took me 6 months to build this, 6 months to build, it didn't take long. It took me 5 minutes to build your military.
Well, I can tell.
Yeah. It wasn't great, but I thought it would pass.
We're persuaded.
It was a beta. It was a beta.
Yeah.
Any other questions? Okay. There you go.
Well,
Thank you,
everyone.
Thank you. If you have any other questions, just send them my way. I'm happy to answer anything. If you need anything, if you want a model to help you with anything, let me know.